Okay. Next article is rectangular bar subjected to a system of forces, right? In this, what happens is, actually in the last case there was the same rectangular bar, but that rectangular bar was under the action of only one force in one direction. Now it is the case in which this rectangular bar is under the application of three forces in three different directions. One is along x-axis, so sigma x is there. Then another is along y-axis, sigma y is there. And then one is along sigma z, and this sigma x, sigma y and sigma z are the corresponding stresses which has come out because of the value of force applied along these axes, right? So sigma x we can always calculate, that is the force applied along this axis, and divided by force divided by area of cross section. Similarly, in this, for sigma y we can calculate force, let's say Py, force is applied, and that to be divided by this lamina. Same for sigma z, let us say Pz divided by this lamina, right? Okay. Next is, we have to calculate the same strategy we have to apply. We have to calculate the change in length of the bar. Let us say along x-axis it is having a length of, let us say okay, let's say L, right? Let us say along y-axis it is having a length of B. Let us say along this it is having a length of T. No issues, right? So strain in x direction, right? Okay. So we can always say that it will be because of three factors, right? It will be because of sigma x, then it will be because of sigma y, then it will be because of sigma z, right? So strain because of sigma y, strain because of sigma x, strain because of sigma y, and strain because of sigma z. Then if we write this, then we always know that sigma, because of sigma x there will be increment in the length of L. Because of sigma x there will be increase in its length, right? So this factor has to be sigma x upon E. No issues. I know this, I can always write down, right? But because of sigma y, because of this factors, because of this sigma y, sigma x will compress. Because of this sigma y, there will be length will decrease. I am again trying to show you. Because of this sigma y, there will be decrease in the length L. Okay, what will be that length? That decrease in length will be equal to Poisson's ratio. And what is Poisson's ratio? Is mu is equal to delta lateral strain upon linear strain, upon linear strain. So in this case it should be minus sigma y upon E multiplied by nu, right? Because of this it has come up in this shape. Then for the third case it is same, mu multiplied by sigma z upon E, right? In the same way we can write down Ey as sigma y upon E minus nu into sigma x upon E minus nu into sigma y upon E. Sorry, sigma z upon E. Same way, Ez is equal to sigma z upon E minus nu into sigma x upon E minus nu into sigma y upon E. Once again, I wish to clarify you that if I study the change in length of L, then because of sigma x it will decrease, but because of sigma y it will decrease, right? Because of sigma z, this length L will decrease. Now because of sigma y, how much it will decrease? It will decrease equal to lateral strain, and that lateral strain is equal to Poisson's ratio multiplied by linear strain. And linear strain along y-axis is sigma y upon E multiplied by nu. Same way for sigma z, and the same concept I applied everywhere, right? And as we already discussed in the last formula, that volumetric strain is the summation of Ex plus Ey plus Ez. That is the linear strain in three directions, right? So in the same manner, if I apply the same formula in this, then Ev is equal to, I'll equation 1, equation 2 and equation 3. If I sum up these three equations, then it will be Ex sigma x plus sigma y plus sigma z upon E multiplied by 1 minus 2 nu. This will be the outcome, right? And if I do so, then Ev will be, and if there is a special case when sigma x is equal to sigma y is equal to sigma z, then these three will be equal to sigma. Then it will be 3 of sigma upon E multiplied by 1 minus 2 nu. Or I can write down this as E is equal to 3 into sigma upon Ev into 1 minus 2 nu. Or E is equal to 3 into K, where K is called as bulk modulus multiplied by 1 minus 2 nu. And this is one derivation between elastic constants, right? Thank you.